The last section that we'll talk about for Chapter 2 is Section 2.4, and it revolves around writing linear equations. Our objectives for today is that we will be able to use a given point and slope to write an equation in slope-intercept form, and then we're going to talk through 3 different strategies you can use to do this process, and ultimately you will get to choose the process that's best for you, the one that makes the most sense. I'll share the one that makes the most sense for me and the one that I choose to use, but you can certainly choose which one makes the most sense to you. And so most of us are already familiar with slope-intercept form, this y equals mx plus b. It's best to use slope-intercept form when you are given the slope and a y-intercept, or when you're working from a graph that has an obvious y-intercept. It's really obvious where the line crosses the y-axis. In this case, m is the slope and b is the y-intercept. This is something that I hope that you are very familiar with from Algebra 1. The one that you may not be quite as familiar with is point-slope form, but this is something that tends to be very useful if you take the time to learn this particular formula. Point-slope form is really helpful when you know what slope you're using and any other point. It makes it very easy to rearrange your equation without having to find the y-intercept directly. And so here, m is the slope still. y1 is the y-coordinate of the point that you know. And then x1 is the x-coordinate of a point that you know. So you don't have to know the y-intercept like you did here. For this one, you could know any point on the line. And so we'll talk through how to use both of these today. One other thing that we want to review from geometry is the relationship between parallel and perpendicular lines. Parallel lines are two non-vertical lines will have the same slope if they are parallel. So we know that parallel lines have the same slope, and vertical lines are always parallel. Vertical lines are our special case because the slope is undefined. So we wouldn't say that they have equal slope, they just have undefined slope. Perpendicular lines, on the other hand, we know that two lines are perpendicular if the product of their slopes is 1. Okay, that means that the slopes of perpendicular lines are negative reciprocals. Sorry, not one, negative one. Negative reciprocal. So for example, if I have a slope of 4, the slope of the line that's perpendicular to that would be negative 1/4. I flipped it over. Similarly, if I had a slope of negative 2/3, the negative reciprocal of that, or the slope of a line perpendicular to that line, would be 3/2. So I'm taking the reciprocal of the fraction and I'm changing the sign. Over here, my slopes have to be the same. For perpendicular lines, it's the negative reciprocal. And so they give you a little bit of an example here. These two lines are parallel. They both have a slope of 4. This line is perpendicular to both. We know that from the box here in the corner. And that slope is a negative 1/4, which is the example I gave you here. So let's flip to the next page that talks through the 3 different strategies you can use to write linear equations. The first is to graph the line, count the y-intercept, and graph the information from there. So for example, write the equation of a line in slope-intercept form that has a slope of negative 3/5 and passes through the point 5, negative 2. So in this case, the first thing I would do is plot the point, 5, negative 2. So 5, negative 2 will be right here. And then I want to know what the slope is. What the y-intercept is. And so it's important that I